Hello everyone. In this video I'm going to go over how to solve some word problems about right triangles and trigonometry. So for this first problem, it says a 20-foot ladder leans against a building so that the angle between the ground and the ladder is 72 degrees. How high does the ladder reach on the building? Part A, we're going to draw a right triangle representing the situation and label the parts you know, put a variable on the part you want to know. Okay, so let us draw a picture. So I've got a building, just a really crude building here, and then I've got a ladder. The ladder looks like a line, basically, and then I have some ground, and hopefully the ground is at a right angle to the building, because otherwise I can't solve this problem. So this should be a right angle here, hopefully. And what do I know in this situation? The angle between the ground and the ladder, so that's here, is 72 degrees. And I'm told the ladder is 20 feet. So this distance on the hypotenuse there is 20. So this is my right triangle. And I need to also label the part that I'm trying to find. And that's this height here. So I'm going to call it H for height. Okay, so now you can see I have a right triangle with an angle and two sides are labeled. So I just need to pick the right trig ratio to use here. So in relation to my angle, the side that's touching it here, that's the adjacent side. The side that's not touching it over here, that's the opposite side. And then the longest side that's across from the right angle is the hypotenuse. So the ones that I have labeled are hypotenuse and opposite. I've got a 20 and an H on those, and I don't care about the adjacent. So I'm going to use which trig ratio. Here's my little mnemonic, so, ka, to, ah. And so I have opposite and hypotenuse labeled, so I'm going to use sine. Okay, so this will be sine of 72 equals opposite over hypotenuse. And now I just need to solve for h. So to isolate h, I just need to multiply both sides by 20. And that's it. I'll just put it in a calculator. Now you're going to want to make sure your calculator is in the right mode. See the little deg here? That means I'm in degree mode. Your calculator should have somewhere on it a mode button or a degree button or a rad button so you can change modes. I'm given this angle is in degrees, so I want to stay in degree mode. Okay, so I'm going to do 20 times sine 72. Okay, and I'm getting 19.02 approximately. And now lastly, for any word problem, figure out a way to check it, or if you don't have time to check it, ask yourself at least if it makes sense. Like, could this be the height that the ladder reaches on the building, 19 feet? Well, if I got like 25, I know it's wrong, right? Because the ladder's only 20 feet. If I get something super small, like 1 foot, that would also be really weird because nobody can put a ladder at such a, like it would be very difficult to put your ladder that shallowly and nobody would do that. But 19, I mean, that seems really high. But yeah, I guess it could be right. Okay, so that is problem 1. And let's look at problem 2. The angle of elevation to the top of the Empire State Building in New York is found to be 11 degrees from the ground at a distance of 1 mile from the base of the building. Okay, so I'm just going to draw a building again, and all my buildings look like rectangles because it's just a math problem, so rectangles are good. You can put a little door in the bottom if you want, though that's way too big for the Empire State Building, I think. Okay, and then we have the ground. And we've got somebody standing a mile away. So this is going to be like 1 mile distance here. And they're looking at the top of the Empire State Building. So they're looking like this. And they've got a little protractor with them holding it up to their eye. Or they've got some surveying tools to measure this angle here. And this angle is, that's the angle of elevation. So that is 11 degrees. And what do we want to know? The height. so this will be h. So it's very similar to the last problem, except that we're given the adjacent side instead of the hypotenuse. So the two sides that we've labeled in relation to the angle here are adjacent and opposite. So we are going to use tangent. So we're going to do tan is opposite over adjacent. So tangent of 11 degrees equals h over 1. Well, that was easy. It already solved itself. Okay, the height is just tangent of 11. It's dividing by 1 doesn't do anything. So I'm just going to put that in my calculator. Tangent of 11, tan. Make sure you're in degree mode. And I'm getting 0.194. That might seem small, but this is in miles. So this is like about 20% of a mile, a fifth of a mile. That's something like 1,000 feet, around there. So yeah, that could be right for the height. Okay, so this is miles. Last example here, we are given a diagram. So a 50-foot pole casts a shadow of 20 feet, see the figure. Use this information to find the angle of elevation of the sun, theta. Set up an equation using a trig function and solve it to answer the question. Okay, so here's our, let's redraw the triangle. This is 20, 50, and theta. Okay, so in relation to theta, the two sides that we have are adjacent and opposite. This is the right angle. So we're going to use tangent. The angle is called theta. So it's opposite over adjacent. 50 over 20 is the same as 5 over 2, so that's 2.5. And now what do we need to do to solve for theta? Someone suggested to me once that we should divide by tan. No, this is not multiplication here between tan and theta. This is a function. You can think of this like a mysterious box that theta has been locked in. And the only key to get theta out of this box is the inverse tangent function. So what I need to do is apply inverse tangent function to both sides, or you can just skip right to, oh, sorry, this one's not inverse. So I'm basically putting both sides of the equation inside of the tangent inverse function. Okay, because I have to do whatever I do to both sides. And now this is the key that opens the tangent box. Those two are going to cancel each other out. They're designed to cancel out. So this is going to give me theta equals tangent inverse of 2.5. If you want to skip right from tangent of theta equals 2.5 down to theta equals tangent inverse of 2.5, that is totally fine as well. I tend to like thinking of it as popping both sides into the same function, but whatever works for you is fine. Okay, so we're just going to put that in the calculator. Second tangent 2.5, and be cognizant of what mode your calculator is in, because the angle you get back is going to be in degrees or radians depending on what mode your calculator is in. For an applied problem like this, most people would want degrees probably, because that's more understandable to the average human. So 68.2 degrees. Looking back at our triangle here, this side is kind of short compared to this side. It's a bit longer, so 68 degrees, yeah, seems okay. All right, that is it for this video, and I'll see you another time.